welcome back to Pinnacle Drilling with myself, Gordon Sezeki. Once again, back on the LB35 OKUMA lathe. It's July 4th. Happy America Day. And, you know, up here in Calgary, Alberta, it's the first day of Stampede. If you've never been to this area of the world, Stampede is about to be in full force. 10 days of awesomeness. So that's my inspiration for today's video. But today, I'm going to be making an 8.6 UN thread. So 8.6, 8 UN thread. My material is coming in at 8 3/4 solid by about 6 5/8. So as you can see here, it's hard to see probably from the camera angle, but both sides of this part have the same type of thread, 8.6 UN on both ends, except for over in this little area here, it's going to have a through hole, or sorry, not a through hole, a blind hole that we're going to bore open to 4 3/4 and make it flat on the back. We make a lot of these custom straight threads here at Pinnacle to our own specifications. So today I'm not actually going to use measure over wires to do this, because we have a certain technique that we use when we do the threading with the lay down insert via Kennametal. This is kind of our strategy for turning the external and internal inserts threading for that job. I have selected my jaws. My jaws have a nice healthy backing to them so that it's easy for me to clamp onto it, and it's going to be nice and rigid. Now, from some of the other videos, I've seen in the comments that some people wanted to see a little bit more of the programming on some of these parts. So I'll go into a little bit more in depth on that for you guys today. So I got my bolts in. Now, clear up my jaws. Okay, so I'm going to call up my boring bar to that 8 3/4 OD size. So G00 T08 X 8.75. So I put that into MDI. Now I'm going to hit go. And my boring bar is now at 8 3/4. So from there, put it into manual, and I'm going to bring my turret over to the chuck. Okay. And from here, I'm going to grab my first jaw. So this one says number 3 on there, so I'm going to put it onto jaw number 3 on the chuck. Bear with me. Place that in here. Okay, bring this guy over here a little bit. All right, so as you can see, my tool tip is right at the bottom of the jaw, and I want to be in the middle of the stroke because this chuck is actually an air chuck, and when these jaws go in, you want to be in the middle for the best clamping pressure. If you're too high, it might not be in the most likely spot, and it can let go of parts. Bring it up. Lock those in. Okay, now I'm going to bring up my tool so that it's something for me to place all the other jaws in a line with it. The same one, I don't have to count. I can just place it back right onto the top of that insert there in the same spot. Okay, number 3. those are lightly screwed in. Move my boring bar out of the way. Get the part into the machine just to eyeball if that's correct, because before I lock it all down, I want to see if it's good. So that looks like about right. Maybe I'll go one more click up. Yeah, I'll go one more click up. One more back. All right. Now, let's place the part into the machine. My rule of thumb for CNC is, in order to set up and make an efficient setup, I have kind of like three or four groupings of strategy. One, look at your blueprint and look at your part and focus on work holding first. That's the number one thing, is to get your work holding started, then your tools, and then write a program, because if you write a program and you don't know what your work holding is like, then you might have to go back and make some changes. So it's kind of good to focus on good work holding first, then tools, then write a program. That's my opinion. So up it goes. Okay, adjust this a little bit. Awesome. Move that out of the way. So you can kind of see on the chuck right here that this is indented or recessed in from the top right here. Now, when I measure from here down, the maximum stroke is 170 thou, okay? So when I take my vernier and I measure at the center, I'm at 90 thou. So 90 minus 170 is approximately in the middle of that stroke. Bang on, boys. Let's get them. Now that I have my drilling tool in and my threading, everything else is touched off already except for these two tools. So I got to go and create that reference dimension in my tool offset. So I'm going to go ahead and create a face and an OD to touch off both tools, okay?
A few moments later.
And now, I'm going to go to MDI, or well, directory, new file. So I'm going to enter my blueprint number 4086-5 op 1. Okay. In this screen here, it's asking me what kind of material I'm going to be using. So 4140, and I'm going to come in at 8 3/4 by 6.375. I'm just setting the blank stock in this IGF. So from there, I'm going to create facing. So I'm going to use a cutting speed of 425, 18 thou per revolution feed rate at a depth of cut of 1/16. I'm going to leave 8 thou for finishing on the Z. So I'm going to enter in those parameters. I'm going to be 8 7/8, 100 above the part because it's an 8 3/4 part. 125 thou for facing. Now I'm going to do OD turning. So I'm going to use a cutting speed of 400 by 16 thou per rev and a 1/4 inch depth of cut or 1/8 depth of cut per side. I'm going to leave 20 thou for finishing on X and 8 thou for finishing on Z. So over here, I have my start point right here, which I'm going to create these threads here. So 7.826 Z0. Taper it up. Taper it up to 0.4375 minus 5 thou. 8.432 at 30 degrees. Up. Z length 5/8. Taper it back up. Okay, so then I'm going to do the thread OD. 6 at 45 thou. And in a different screen, 3.5, 0.450, 50. Then come up to 8 seconds. Okay. Now I'm going to zoom in on this guy. Just add a couple radiuses into this. So 20 thou right there. And on that little corner, I'm going to put 20 thou as well. Then I've got to do the deburring. That's done. Now I'm going to add my drilling with the 3-inch U drill. So tool 4, 3-inch. And I'm going to run 350 per cutting speed by 4.5 thou per rev. It'll be about 500 RPM. I'm going to start at a 1/4 inch away from Z0. So the blueprint says 4.31 for a flat base. Okay, so that's what I'm going to enter in. Now I'm going to do my boring. So 2-inch DVI bar is started off at 3-inch ID because that's where the hole starts. And I have to go to 4 3/4. So 4 3/4 Z minus 4.310. Face it down to 2.8. Okay, you can put a little chamfer here. That's 60 thou the blueprint's calling for. And there's a little radius over here of 1/8. 0.13. So there's my little radius. Awesome. Now I'm going to bring in finishing for the ID, which is tool 8. 700 cutting speed for finishing by 10 thou per revolution. And the awesome thing about the IGF is I can just copy and paste the geometry I wrote for roughing. Cool. Finish the OD. Okay, so I just got to change the start point so that I'm not finishing the face down. I'm going to start here, drag up for the finishing, and go over. So I need to know this number. I usually just type it in my calculator, and then I adjust for coming downward. As you can see, that kind of went all fucking weird. But then you enter in that other number I wrote in my calculator, and it brings it back up. 6. Cool. So for threading, thread the OD, tool 12, 60-degree tool at 1/8 for pitch, because 1 divided by 8 equals 1/8. So 1/8 thou depth of cut and 1/6 thou depth of cut for finishing. So 75, 0.5. And this is where we use the little technique without having to use measure over wires. You program your part to 5 thou above the major diameter, and then you bring the tool 12 down minus 5 thou. When you measure the OD after OD finishing, and it measures 8.6, then when it threads, you want it to measure 8.595. Then you know you have full thread depth, and that's how we do this kind of thread at Pinnacle Drilling. It's a little bit loose, yes, but that's how we do it, and we don't have to do measure over wires every single time. Or you could buy a gauge, but we do so many different sizes of this. This is the technique that we do to the OD and to the ID of UN threads for our product. So that's what I'm going to enter in. So to calculate thread depth on a UN thread is 0.6134 times the pitch. So 0.6134 times 1/8 is 76 thou, approximately. Awesome. That's it. Now I can process test the simulation here. So here it comes in and faces, turns the OD, drills, and is now going to bore. Ignore this little tip right here. The IGF shows a an included angle of the drill. Finishing. And OD finishing. And here's my threading. Looks great. So now I'm going to post my program. 01 is my program number. Process and save into MDI memory. Now I'm going to read through my program and make sure everything is all good. So I'm going to change my G50 to 650 RPM. I don't think we need to spin it any faster than that. Okay, that looks okay. So just before tool 1, I put in I changed the M01 to an M00. RPM 500 for a 3-inch U-drill. Let's keep that out. Take that out. Cool. Everything's looking pretty good in here. usually just have to mess around with the drilling a little bit. All this looks great. Finishing. On the one angle over here, it's got a 32 RMS finish. So I'm going to change that. For a portion of this G-code will be 5 thou per revolution. To get that seal finish there. And then on this line where it moves over, I'm going to put it back to 10 thou. From there, put an M0 right before my threading. I'm threading, my RPM for threading is 189. That seems okay. Maybe let's just go to 190, make it a whole number. That looks great. And I just got to change a couple M codes, M32 to M33, and this M74 to M73 to M74. Otherwise, everything else looks great. Cool. Let's get her. Cut. Remember, I put in almost 1/8 by 62 thou, so it's going to take 2. Now we'll take a healthy one. So, we have a nice clean face. Looks great. All that cleaned up there. Cool, so now we're gonna go into turning. So, there's the 400 cutting that's our roughing. Okay, got the OD. This little angle, it's hard to see. That bevel, straight, bevel, up. Okay, that's good. Now remember, this is all first off stuff, so I'm slowly going in. I'm looking at my load as I'm turning up my feed rate. Got probably about 1 more inch to go on the distance to go. Okay, and now it's about to wrap it right out of the hole, straight out. There we go. Nice. Okay. So, like a machinist would, kind of take a look at what your chips look like. Okay. So a lot of these bigger guys are coming from the upper section of the U-drill, and of these lower ones, these smaller, beautiful 6s and 9s, they're coming from these guys. Now, I probably could say I could push a little harder to break these ones out a little bit more, but my load was already at 100, which is pushing pretty hard for a 3-inch U-drill. You know, and trying to not get long, stringy chips, finding that happy medium, right? So every day is a different day on working on how good your chips are. I think that this chip management is acceptable. Now let's bring in tool 6. Alright, so that's what it's looking like inside. Just the littlest bit of a backing there, right? And there's the U-drill mark. Left a little bit of a tit, which I'll grind off. That means that my tool could have came up a little bit more on the drill, but that's okay. It happens most of the time. So it's going to come in here and finish and come back down here. I just need that flat back right there for this job. Okay. Here comes the finishing tool. See in there, it's nice and flat. I'm going to finish the OD. There's that 32 finish right there. Last off the red. Now let's thread. There we go. Just pass. Everybody likes to see these threading passes. Yeah, look at that. Okay, I gotta turn on the coolant, so what I got going on. Little thread. Looks nice and beautiful. No chatter. Okay. 0.593, right in the middle of the tolerance. That's great. So that is a completed part, from setup to programming to running it as a first off. This is an 8.6 8 UN 60-degree thread. It's got a 4 3/4 ID with a flat back. And on this second side, it's just simply another 8.6 UN with no through hole. It's just the same size as duplicate. So once I machine that, I'll show you the next part of the completion of the part here. But for now, that's a finished part, boys. Thank you for watching. And, you know, we always appreciate any of the views that we have on our videos. You know, we're just doing this for fun. We're having fun. We're making videos. We'll have another video for you guys to watch, because making manufacturing videos is freaking awesome. Anyways, have a good day.